Hello, welcome to Cracking the Cryptic. Welcome back if you are a regular, but I'm also going to give a little intro if you're not, because this is the little corner of the internet where Simon and myself solve especially variant Sudokus. So what's that about? Well, we talk through the logic behind a puzzle that's been sent to us probably, and we'll explain how we're solving it to help you with your ability to solve it. Now, you can always play these puzzles on a link below the video yourself before or instead of watching the solve. We don't mind how you use the videos at all. So that is what is going on here. Now, Simon and I started this channel 4 years ago. We thought we were going to be teaching how to solve cryptic crossword clues to people, but it turned out that we were reasonably good at Sudoku and people were much more interested in that branch of puzzles. So that's what we largely do now. Where do we get our puzzles from, people wonder? Well, we get sent, I reckon, about 10 a day on average. It's a phenomenal number. They cannot all appear on the channel. I'm very sorry. We have testers who look at them. We try and select the most interesting puzzles for you. And we try and flag when they are manageable by people who aren't absolute experts in the field, and we call those approachable puzzles when that happens. So there are a variety of constraints that have been added to the classic Sudoku rules of 1 to 9 appearing in every row, column and box, and this puzzle actually showcases 3 of the more common ones very well. So I'm looking forward to showing that. Now, why I was minded to kind of give you a bit of general background on the channel is that Gonzalo, who sent this in, was actually quite interested. He didn't know if we had any submission preferences for puzzles or if we accept them from viewers. Well, we do. We're certainly interested always. Now, we do have some submission preferences, and if you click on Cracking the Cryptic below the video and go to the community link, you'll find a post in there that we put up a while ago that explains how we prefer you to send us the puzzles. So it mentions, please don't send us more than 1 a month. You won't probably hear back from us unless the puzzle appears on the channel. We are just snowed under, I'm afraid, with puzzles. Try and keep them relatively straightforward in terms of the rules, because if we had to spend ages explaining the rules, that's quite a turn off for people, we think. So we don't like that too much. Also, if there are steps that mean that our testers can identify that this puzzle doesn't require bifurcation, it would be very sensible to include those. A lot of puzzles get rejected as apparently requiring guesswork. So we don't like that. We like puzzles that have logical flows through them. Sometimes those can be very difficult, especially on the longer videos that Simon does sometimes. But you'll be able to judge from the video length every time how hard the puzzle is. Normally when I'm doing a puzzle, if it's done in 20 or 25 minutes or less, then you should certainly think that anybody who can approach these with the normal kind of ideas in mind, and I'll try and explain some of them as we go through this one, will be able to get to the end. So let's have a look at this specific puzzle. And thank you very much to Gonzalo Souza from Portugal, who has sent in his first puzzle for Cracking the Cryptic. It does feature his initials, G here in the thermos, I think, and D down here, and the S down in this corner. That's more obvious. And also his birth date. I believe he says 1152 is his birthday, which obviously makes him a millennial, so a very young viewer. I think maybe, I don't know if 2021 at the top left is the year as well. Now, I should mention, along with the channel, we have various other things. There is the Discord server where people chat about everything to do with Sudoku and other puzzles. Nearly 17,000 people there, the most friendly, welcoming crowd you could find anywhere. That's on a link under the video. If you're a supporter of the channel, you want to help us out, keep us producing more content, you can go to Patreon, and we have a channel there called Cracking the Cryptic. Obviously, again, there's a link under the video. People who subscribe $2 a month are entitled to the monthly reward videos. There are, the monthly reward puzzles. There are sometimes prizes for somebody drawn out of the hat there. We do get hundreds of entrants normally. And people who are paying $3 a month get to see a solution video for those reward puzzles and some other stuff. Today, for instance, we put up a solution video to Sam Cappleman-Lynes' 6x6x6 puzzle, which was out on Patreon a week or so ago. So there's always extra content going on over there. We also have a suite of apps which are available. They all contain genuinely handcrafted, top quality puzzles. And we have Sven's SUDOKU PAD, which allows you to play pretty much any Sudoku, any classic Sudoku in our software, because that's proved quite popular. We have merchandise as well. Yesterday I was wearing a Cracking the Cryptic hoodie, although I failed to display the logo so you couldn't tell. But there's lots of other things available there too. So loads going on with the channel as always. And our regular videos, Simon at 8:30 every day, our time, myself at 11, 2.5 hours later. And that's what you're watching now. So do have a go at this GDS Sudoku by Gonzalo on the link under the video. Thermo, Killer, and Sandwich Sudoku. Oh, did I explain the rules? I don't think I did. I just told you how his initials appeared. Let's go through the rules. So we have Thermo Sudoku. Numbers must increase from the bulb of a thermometer to its end. So that number will be smaller than that, will be smaller than that, will be smaller than that, will be smaller than that. Killer Sudoku, so the cages show their sums. These two digits must add up to 11. And Sandwich Sudoku, this is perhaps the more complicated one, but a bit of a favorite. The number outside the grid, so this 20, for this column, shows the total of the digits that are sandwiched between the 1 and the 9 that must appear in that column. So the digits between them will add up to 20. They could be 875, or there could be more of them than that. In this 0 column, the 1 and the 9 must be next to each other because there is a 0 total of digits between them. So that's how this works. Do give it a try on the link under the video. Longer introduction than usual, but we're there now. Going to crack on and let's get cracking. And we get given a digit basically by a single digit killer cage. If the total of this cage is 2, the number in it is clearly a 2. And that can lead us on very handily to the next killer cage. This is in the same box, so it can't have another 2 in it by the rules of Sudoku. So that must be made up of a 1 and a 4. We don't know. This now 11, there are 4 2-digit 11 combinations. This one can't be 2-9 because we've had a 2 in the cage. It can't be 4-7 because in one of those two places we've definitely had a 4 in the cage. So this is either 5-6 or 3-8, and I don't know which. 16 in 2 digits, I think everybody can do that. Given that they're Sudoku digits, that must be 7 and 9. This 9 though, there are 4 possibilities, so that's not so helpful. Now, Simon thinks I am renowned for pencil marking thermos, by which we mean writing either the... So we use 2 types of pencil mark. The one I've used so far, we put in the middle of the cell, and that shows where the numbers for that cell must come from that population of digits. So this cell must contain a 1 or a 4. The other thing that we sometimes do is put numbers in the corners when we can isolate where a number is. Actually, here's an example. If there's there's obviously a 9 in this box. That's a knowledge bomb for you. Where does the 9 go? Well, there's a 7 and a 9 already in this column, so it doesn't go in those cells. It can't go in these cells because they're on a thermo, but not at the end of it. So there has to be bigger numbers in that thermo afterwards, i.e. here. So they can't be 9s. So the 9 must now appear in one of these 2 cells. The same argument applies for this. It can't be a 9 because there are bigger numbers on the thermo. So 9 will appear in one of those, and this corner mark shows that what I'm doing in this box is saying that 9 is confined to those 2 cells. So we use these 2 types of pencil marks. Now, actually, I am going to do some what Simon calls goodliffing. The word has made its way into the Urban Dictionary for some reason. And it's just where we put all the candidates on a thermo sometimes to show what they can be. Now this clearly can't be 7 or 9 because they're already in the box. And because the numbers have to ascend, it has to be at least 6. So we get this trail of possible numbers. Now, here's a very useful technique for sandwich Sudoku, and I'm going to use this now. Every time you know that a cell isn't a 1 or a 9 in a relevant row or column, it's worth colouring it, and we like to do green for some reason. Don't know why, that's just what we do. So in this row, where the sandwich adds up to 30, all of these are green because we've pencil marked them. None of them can be 1 or 9. That means the 1 has to be here somewhere. I say that because the 9's already done in the box in that cage. So the 1 is in one of those cells. The 9 must be over here. The numbers between them add up to 30. Now, the secret that we sometimes communicate is that the numbers 1 to 9 add up to 45. So every row, column and box of a Sudoku add up to 45 because they all contain 1 to 9. Now in this row, we know that the sandwich digits add up to 30. We also know that the 1 and the 9, the crusts as we sometimes call them of the sandwich, add up to 10. So that's 40. If we subtract that from 45, the total of the row, that means that the digits outside the sandwich that aren't between the 1 and the 9 and aren't 1 or 9 add up to 5. Now that could be done in 2 ways. That could be a 2 and a 3, but that's no longer possible because we've used the 2. We know the 2 is in the sandwich somewhere, so it can't be outside it. So what is outside it is a 5. So there must be a 5 in one of these 2 cells. And then if the 5 is here, the 9 will be there and the 1 will be there. If the 5 is here, the 1 will be there and the 9 will be there. And I don't know what the answer to that is at the moment, but I do know that the 5 is on the outside, so it's not in the sandwich, so none of these have a 5. And now this cell has become 6 or 7. This has to be bigger. It can't be 6 anymore. That has become an 8. That is our second number in the grid. So there's going to be a 5 outside. Now this pencil marking is not quite what I said I would do. I said I'd put numbers where corner marks where a number was confined to a couple of cells in a box. What I'm actually using 5 for here is in the row, but it's really an aide-memoire for me at the moment. So let's just have a look down this column now. Right, this is interesting. So we've got a 21 sandwich sum, and we know that 9 is up here somewhere. So the sandwich has to contain at least that 8, must contain one more cell here at least, because even if that was 9 and that was 7, then you'd get to 6 here. But here's a little tip as well. If you get sandwich and thermo combined, the cells that aren't on the bulb or the tip of a thermo can never be 1 or 9, because 1 must always be on the bulb if it's on a thermo, 9 must be always on the tip. So all of these cells can be shaded green as we were planning to do. And that means the 1 can't be anywhere here. The 1 is somewhere down here. Now, how far down can it be? It can't be all the way here. Let's do this trick with 35 minus the sandwich clue in this column. 35 minus 21 is 14. So the outies, the numbers that are outside the sandwich, add up to 14. Now, that could sometimes, if the 9 was here, the closest the 1 can be now is here. Then there's only 2 cells outside. And can they add up to 14? No, they can't, because they can't be 9, 5 anymore, because the 9's been used. And they can't be 8, 6 anymore, because the 8's been used in the column. So in fact, the 9 cannot be here, and we've proved that that must be the 7. The 9 is here. Let's just colour the 7 so we maintain it for the columns that matter. Now, the sandwich is going to add up to 21, but remember the outies add up to 14. Now, how many outies are there going to be down here? Clearly this one. We've only got 7 towards that 14 sum. And it can't be just this one, because it would have to be another 7 to make the outies add up to 14. So this is an outie as well. And now we know that the 1 is here in the column. So let's remove the pencil marks there. And we've got a 1 here. Now let's have a look at this 28 column, row that's in. 2 outies there. That is clearly green. The only white cell left is here. That's a 9. These two outies have to add up to 35 minus 28, which is 7. And because they're not the smallest numbers on a thermo, they can't include the number in the bulb, which also itself can't be 1. So I think that's going to have to be 2 to allow these two to add up to 7 by being 3 and 4. And again, we've got a pretty decent start. Now I'm going to pencil mark this thermo here. This cell can't be 3 or 4 because they're in the box already, so that's 5 or 6. Now the only place for 3 in this column has become here. And then the only place for 4 has become here. And we're left with just a 5-6 pair to finish in the column. Now, what about this thermo? I'm going to pencil mark that as well with the candidate possibilities, but I don't know how they pan out yet. Now, this thermo is quite interesting. It could begin with a 2, but other than that, it's going to have to go 5, 6, 7, 8. So, again, we can goodliff our way along it. Now, hang on, is 8 okay here? There's still another cell, but that cell can be 9 because that 9 is not operating as it does on those. It doesn't see that cell. So that is 8 or 9. This is fine. This could be anything that's not 1, 3, 4 or 9. And you can see that these, you can check your maths if you like. These must be made up of 2, 5, 6, 7 and 8. If you add them up, you will find they add up to 28. So we're getting the sum right for the row. Now, does that give us anything else? I don't think this 0 column is very useful. We know the 1 and the 9 will go together in it, but they could be in any of the 3 boxes. What about this 20 column? We know the 9 is down in one of these cells. Right, can this be the 1? We need to do the maths on this a bit. So maybe we'll think about the outies again. If the number in the column is 20, the clue, the sandwich clue, then the outies are 35 minus 20. They must add up to 15. Now, could this be 1? Actually, hang on, maybe the better way to go is how many cells are in the sandwich? Well, it's got a 3 in because the 9's down here and the 1's clearly above that. So there's got to be 3, 8 and 7. Remember, 9 can't be in the sandwich, it's one of the crusts. 3, 8 and 7 only adds up to 18. So a 3-cell sandwich is not big enough. So the sandwich is at least 4 cells big. Now that could include this one if the 9's down here. And at most, the sandwich could be 5 cells, 2, 3, 4, 5, 6. So I suppose that could be the sandwich with a 9 here. Oh no, this can't be a 1. There's a 1, 4 pair there. Okay, let me just green out those cells. This can't be the 1 because you could never get the outies to add up to 15 in this column. So that's not a 1 or a 9. In fact, nor's that because there's a 1 there and there's a 9 there. But I'm not sure in this column whether the 1 is here or here. So can't make more progress on that unless I'm missing something. Right, now what can we do next? We've used a good portion of these clues. Oh look, this can't be a 9, sorry. If you've been shouting that at the screen, that's another tradition of the channel. People shouting at me for things I should have been able to see earlier. That can't be a 9, so the 9 is here. The outie 5 is there. The 1 must be here. That's not a 1, that's green now, as is that cell. And now the 1 in column 2 has to be here. That must be the 1. Now we said the sandwich has to be 4 cells, so they're all green, and the 9 goes down here on the thermo at the bottom. Let's remove the pencil mark. Now these 4 add up to 20. Might be simpler to consider these 3 adding up to 15. Now they can't include a 1, a 3, a 7, 8 or 9. So they're from the population 2, 4, 5 and 6. If you add those up, they're 17. So clearly the one number excluded to make them add up to 15 is the 2. And they must be a 4, 5, 6. This one can't be 5 because we've got a 5 over here. That gives us a 4, 6 pair in the row, and we can fill in the other 2 cells that can't be 4 or 6. 4, 5, 6, 1, 3, 9. That is 7 or 8. And these are from 2, 7, and 8. And this sum of 2, 3, 7, and 8 adds up to 20. So that's right. Now, this is interesting. This is a little thermo technique. This cell can no longer be a 7. Why do I say that? Well, that's because this one has to be bigger. So if that was a 7, this would be a 7, 8 pair. But we've said that this cell has to be 7 or 8. So that can't be a 7, 8 pair in the same box. So that's not a 7. And now we can see there's a 5, 6 pair formed in the box. So this one can't be 6. And we learn about a 7, 8 pair here as well as a result. So that's dealt with the 20 column. In this 0 column, this cell now can't be a 1 or a 9 because they have to be next to each other. And since that can't be a 9 or a 1, this one isn't. Either the 1 or a 9 is down here, or they're in those cells or those cells, which would make this a definite 1. And that does look possible. Right, what else can we get going? I've probably made something else available and not spotted it. In this 12 row, haven't really worked out much about that yet. Here's something though. The 9 can't be in these cells, and it can't be there. Not that interesting. Okay, that's not that helpful. Let's have a look at this thermo. It's quite long, so I'm going to pencil mark it now with 1, 2, 3, 4 there. 2, 3, 4, 5, 3, 4, 5, 6, 4, 5, 6, 7, 5, 6, 7, 8. But in this row, we now know where the 2 goes because we've got 5, 6, 7, 8 as a quadruple there. Or in other words, this could never be a 2 because it's far too far along a thermo. So the 2 goes here. Where does 2 go in this box? Now that's quite an interesting question. Because of this 2, it can't go in those cells. So now, because of the markings on the thermo, or the length of the thermo, 2 has to be in one of these 2. Maybe that's not that interesting, but it might help a little. These can't have a 5 in because of the 5 at the top of the grid. That 5, much more importantly, has ruled out a 5, 6 pair in the 11 cage up here. So that's a 3, 8 pair. We get a 6, 7 pair there. So now this can't be a 6. And once this cell is down to 3 or 4, this has to be smaller. That's 2 or 3. This one is now 1 or 2. Let's do some green colouring just because I might as well get the whole grid going as far as I can. Yeah, it's actually worth pointing out, for instance, this cell sees a 1 and a 9, so it clearly can't be a 1 or a 9. There aren't that many to pick up like that in this puzzle yet, as far as I can see, but it might be useful later. Right, let's have a look at this cell, which is in the 9 cage. It can't be 4, 5, or a 6, 7, or 9, which would have been obvious from the 9 cage. So that is 1, 2, 3, or 8. That makes up 9 with 8, 7, 6, or 1. Now, is that any use? Let's have a look down this column. Yes, this is quite interesting. We've got 6, 7, 5, and 9 sort of placed. I mean, actually the 6, 7 are resolved. I've only just seen that from this 7, 9 pair over there. So that can't be a 6. Fair enough. Right, we've got 6, 7, 5, and 9 placed. And down here, we don't know exactly what they are, but we know they don't contain 1 and 8. So in the column, 1 and 8 must be in these cells. 1 must be in one of those. 8 must be in one of these. And that means in the box, 1 and 8 is confined to those 3 cells. So this can't be 1 or 8 anymore. That means this can't be 1 or 8 because that would be needed to make up 9. And therefore, we can actually suddenly place The 1 is definitely here, and the 8 is definitely here. And we've got this down to one of 2 possible fills, neither of which contain a 1 or a 9, which might be useful for the 12 row. In fact, we get a 2-3 pair, might as well not ignore this in the final column. So this is a 4, that can't be a 4, this can't be a 5, we're not getting any. Oh, that 8 has made this a 9, and that means these are all green because we've used up the 1 and the 9 in the box. And now we know about the 12. Well, we know a lot about it. We know that one of the crusts is here, and that must be the 9 because it can see this 1. The other one's in one of those 2 cells, and the sandwich is either these 2 or these 3. Oh, look, that's lovely. If it was all 3, well, if this is an 8, it's just 2. That already adds up to 12. If this is a 7, that's no good because we'd need another 1. But 1 can't be in the sandwich, 1 is the crust. So the only way for this to be a 3-cell sandwich would be if it was 2, 4, 6. But that would leave these cells to be 7 and 3, which do not add up to 9. Another brilliant knowledge bomb from Cracking the Cryptic. 7 and 3 doesn't add to 9. So this can't be a 3-cell sandwich, so that is where the 1 goes. This must be an 8 to make the maths right. That fixes 7 and 2 in the column. That 7 puts an 8 here. And we are literally away. Now, we've done that. We've done almost all the sandwich clues. And now we can finish off with the last one. I said earlier that in this column, the 1-9 pair was either down here or one of these 2 pairs. But now look, we've got a 1 in the box and it's not in any of those cells. So they can't form a 1-9 pair. So they must be green. 9 and 1 must be down at the bottom here. That has used up all the sandwich clues. We've got white cells. Actually, we can fill them in. Sorry, 1 there, 9 there. These must be green. Just wondering if I can complete the colouring so that we can just move on after that. I think I can. That's green. So this is a 9. And that's all the 1s and 9s in the grid. As soon as I write a 1 in that cell. So this has become a 2 now. That makes that a 3. 8 must be in one of those cells. That's not very interesting. Oh, this one should be green. Sorry. There, that can... Oh no, one of those is going green. Oh, in fact, yes, this 4-1 pair has been resolved. So the 4 is green. So there we go. That completes the colouring. That's not a 4 now. Now we sometimes call this a chocolate teapot triple because although we've narrowed down which of those digits goes in which cells a bit, it's still as useful as a chocolate teapot, i.e. not useful. 2 and 3 can be filled in there though. Still haven't resolved this 5 and 6 pair. That can't be a 7 anymore because of this. Wow, what am I missing here? So I've got this thermo. Now, we've either got 2, 7 or 3, 6 here. So that's either a 2 or a 3. That's either a 6 or a 7. And in between them on the thermo is a 5. 6, 7, 8, 1, 9. That is 3 or 5 since it can't be 2 or 4. I think we should be finishing off to an extent here, but I'm not sure I'm seeing exactly how to. So have I failed to finish off a sandwich clue somewhere and do the counting? Oh no, look, this is a 3-8 pair missing from this row. So 3 and 8, that 3 helped me decide which was which. Down here, does that 8 give me something? Not totally. Those are from 4, 6, 8. Oh, I don't know, I'm scrabbling around here a bit now. Still don't know how this 9 cage... Oh yes I do, look, I've got that 3, right. There we go, so 2, 7, 6, 3, that finishes the row. These are from 3, 4 and 5. Does that mean... What does it mean? Something's wrong here. 1, 9, 7, 2, that can't be a 7, that's the problem. This 3, have we done all the 3s in the grid? We've just got a couple left to do. That can't be a 3 anymore. So there's a 3 there and a 3 there. 8, so X-wing on 8s, that's not very helpful. 5, 9, 2. 2 in this box is confined to that cell. That's going to put 2 in column 6 there. That might actually do all the 2s. Yep, they're all done. We've got 4, 6 and 7 to place in column 6. The 7 in this column, I think there's only one candidate cell. It's got to be there. And that puts a 7 here with a 5 or 6 there. This is where 8 goes in the row. I thought I'd broken the puzzle for a second. This is where 8 goes in the central column. It can't go here because of this 3-8 pair. It's still to resolve it, but it's usefully telling us things. That's 4 or 6. We get a 4, 5 or 6 down here. Now pencil marking everything like a fiend. 5 or 7 there. So 6 is in one of those, 8's in one of those. Why is this not? I must be missing some absolutely obvious thing on a thermo or in a sandwich clue here. I didn't mark this. 4, 5 or 6. No, 4 or 5. Because there's a 6 there. Okay, keep shouting at me and I'll eventually hear what I'm missing, which is something blatant somewhere. Isn't it? 4, 2, 6, 9, 1. I know people occasionally write and suggest I should tidy up my pencil marks more often, but I've tried to be fairly rigorous on that, and it's only human error where I've failed. Oh, come on, there is something surely that disambiguates the rest of this. It's this sandwich sum. I forgot it. So sorry. Right, 8, 12, 15 already. This has to be a 6. And that, I suspect, is going to finish off everything else in the puzzle. Which is, it's a bit peculiar sometimes that it does as much damage as it does when you find the one thing you were missing. But when it does happen, it's very gratifying. So that has to be a 7. On the thermo, that is very helpful. We get a 5 there. That makes that a 4, 6, 5, 6, 4, 5. We must have done this 3-5 pair by now, and the 3-8 pair has been resolved by the thermo. Now we can put in, sorry, that's meant to be a 6, 5 there. This has to be a 6, and a 4 to finish the puzzle. And there we go. Very nice puzzle from Gonzalo Souza. I'm delighted he sent it to us. Well worth a go on the channel. Oh, look, that should be green. Dear me. Claimed several times to have finished all the green colouring, and I clearly hadn't. Anyway, there we go. That is the solution to GDS Sudoku. Thank you so much for watching us, especially if you watch us regularly and you had to bear with the full explanation at the beginning. We do get a lot of new people, so it is nice to be able to induct some of them into the ways of the channel. I will see you again tomorrow, and thank you as always for following. Bye for now.